Hi everyone, and welcome to lesson 7.5, Using Proportional Relationships. In this lesson, we're going to explore some applications of proportions, and these are applications you've probably seen before. So let's take a look. The first application is indirect measurement, and this is any method that uses formulas, similar figures, and or proportions to measure an object. So, for example, if I was outside and I wanted to measure the height of the school building, what I could do is use shadows to do that. I would have somebody stand near the school building and measure their shadow and their height, and then I could measure the shadow from the school building and use a proportion to figure out how tall the school building is. And we can do that because the two shadows create similar triangles. So let's do an example of this. Example 1 says, a student wants to measure the height of a statue of a pineapple in Nambour, Australia. She measures the pineapple shadow and her own shadow. The student's height is 5 feet 4 inches. What is the height of the pineapple? Now, the first thing that I notice is that the measurements are given in feet and inches. Now, we can't actually work with that in a proportion. We have to convert it all into feet or convert it all into inches. I always prefer going to inches because when you convert to feet, you'll end up with decimal numbers. If you convert to inches, you'll probably just get whole numbers. So that's your first task. Try and convert the measurements, 8 feet 9 inches for the shadow of the pineapple, 2 feet for the student's shadow, and 5 feet 4 inches for the student's height. Convert those all into inches, and then come back and we'll talk about the next step. Okay, so what I did is I took the student's height, which is 5 feet 4 inches, and I did 5 times 12, because there are 12 inches in a foot, and then I added on the 4 inches to get 64. Now for the pineapple's shadow, I did 8 times 12, plus 9 to get 105 inches. And for the student's shadow, I got 2 times 12, which is 24. Now what we're going to do is we're going to set up a proportion. I like to do height over shadow equals height over shadow. So see if you can set up a proportion for this and solve it to tell me how many inches tall the pineapple is. Okay, so my proportion did the height of the student over the student's shadow equals the height of the pineapple over the pineapple's shadow. So I just did a cross product, 64 times 105 equals 6,720, and that's going to equal 24 times x. Then I just divided by 24 to find out how tall the pineapple is. So the height of the pineapple is 280 inches. Now, to turn that into feet and inches, I just divided by 12. And I like to do long division for that because it makes it easier to find out how many inches you have left over. So if you do long division, you can just get the whole number, and whatever the remainder is the number of inches you had left over. So it's time for you to try it. Check it out. Number 1 says, a student who is 5 feet 6 inches tall measures shadows to find the height, which is LM, of the flagpole. What is that height? So you'll notice they gave you all the measurements in the pictures here, and you just have to find this height. So do that on a Google Doc, and then come back for the next application. Okay, so scale drawings and scale is what we're looking at next. Now you probably remember this from pre-algebra and algebra 1. We use this a lot. But a scale drawing represents an object as smaller than or larger than its actual size. Now, I do have a scale drawing in my classroom. You may remember it. To the right side of my board, there's a picture, a very large picture of a graphing calculator. That is a scale drawing. So the drawing represents the calculator, but it is much bigger than the actual calculator. Can you imagine having a calculator that's actually as big as that poster was? That would be very hard to carry around. Anyway, the scale is the ratio of the length in the drawing to the corresponding actual length. Now you have to be very careful with how you set up the scale. The order is important. It has to be drawing to actual. So that means if I was creating a fraction, it would be drawing over actual. Or if I'm writing it with the colon in between, the drawing comes first and the actual comes second. So let's take a look at an example. Okay, so I don't know if you've ever thought about it, but all maps are scale drawings, because if we had a map that was as big as the thing it actually was represented, well, a map of New Jersey would be as big as New Jersey. So all maps are scale drawings. So let's take a look at this map of Dallas to see if we can find actual distances. So the scale of the map is 1.5 centimeters to 300 meters. And they want us to find the actual distance between Union Station and the Dallas Public Library. Now, one thing to note is that when I put this picture on this screen, I had to make it bigger. So this scale doesn't actually represent, like if you took a ruler to the screen and actually measured it, it's not actually going to be the distance that we need. But if you do it in your textbook and you take a ruler and you measure it, you will get the right number of centimeters. So what I did is I measured it for you and I typed it up, and we'll see that in just a minute. So step one to these problems is always to measure the distance with a ruler. That's our first step. So here's the distance I got. So I got 6 centimeters, okay? So all I did was I took a ruler and I went to Union Station and I put it to the Dallas Public Library over to here, and it ended up being 6 centimeters. So now what you're going to do is you're going to create a proportion. One of the fractions is going to be made from our scale, and the other fraction is going to have the measurement that we got. Now notice the scale mixes measurements. That's okay, because in a proportion, it will automatically give you the units that you need. So you don't have to worry about converting 1.5 centimeters into meters, and you don't have to worry about converting the meters into centimeters. You can just put them into your proportion and everything's going to work out right. So see if you can create that proportion and solve it, and then come back to check your answer. So in my proportion, I took my scale factor and I wrote it as a fraction, and it's going to equal, now notice this was centimeters over meters, so it equals 6 centimeters over x meters. Okay, so I just did a cross product. 1.5 times x equals 300 times 6. Okay, and I got this. And then I divided by 1.5. So x is 1,200. Okay, now this is in meters because this 300 was in meters. So the corresponding parts are going to have the same units. So Union Station is 1,200 meters, or 1.2 kilometers from the Dallas Public Library. Let's do another example using scales. So example 3 is asking us to make a scale drawing for the Lincoln Memorial. It says the Lincoln Memorial in Washington, D.C. is approximately 57 meters long and approximately 36 meters wide. Make a scale drawing of the base of the building using a scale of 1 centimeter to 15 meters. So the first thing we're going to do is we're going to create proportions to find the drawing length and width. You need 2 proportions. So we're going to start off with that. So make a fraction out of your scale, okay, and then take the length and put that in the other fraction. Put a variable for the length of your drawing and solve. Then you're going to do the same thing for the width. Okay, so you're making 2 proportions and you're solving them. So pause the video, try and do that, and then come back to check your answer. Okay, so what I did is I did 1 centimeter over 15 meters equals h over 57. Okay, so I just did 1 times 57 equals 15 times h, and I divided to get h alone, so it's about 3.8 centimeters. Then I made a similar proportion. 1 over 15 equals the width over 36. I did a cross product, and I divided to find the width. Now, you would use a ruler to draw this, and you would end up doing 3.8 centimeters length and 2.4 centimeters width. Okay, now when you're scanning in your pictures, it's going to be hard for me to tell if you're right. So make sure that you actually wrote these, but you really should practice drawing this with a ruler. So if you have a ruler at home, I recommend trying to draw this with a ruler because it's really good to keep up your ruler skills. Okay, so you have a check it out question next. So check it out questions numbers 2 and 3. They say if the distance on the map between City Hall and El Centro College is 4.5 centimeters, what is the actual distance? So what I did is I got out my book and I measured this distance from El Centro to City Hall, and I got 4.5 centimeters. So in your homework, you're going to have to measure yourself. So make sure you have a ruler around. If you don't have one, please send me an email and we'll see if we can come up with a solution. Okay, check it out. Question number 3 says the rectangular central chamber of the Lincoln Memorial is 74 feet long and 60 feet wide. If the scale is 1 inch to 20 feet, how long and wide would the scale drawings rectangle need to be? Okay, so again, tell me how long and wide. I would highly recommend trying to actually draw a rectangle in that measurement, but that would be very hard to do on a Google Doc, and it would be very hard to do when you turn it in for me to actually check your answer. But you should still practice using rulers, so make sure you're practicing that. That's it for this video. You have one more type of example coming up in the next video. Let me know if you have any questions.